Okay guys, so I'm gonna show you how to do the calculations for the amount of caffeine from the experiment that we did. Okay, so and I'm gonna assume a few things here. Let's assume that we used 5 milliliters of the Lugol solution that we have. So this first part here, you don't really have to determine the concentration of Lugol in your write-up. You can just report it instead of saying 1%, report it as the molarity. Okay, but I showed you here how we would calculate that. So if it's 1%, it means we have 1 gram in about 100 grams of solution. So I converted the solution grams to 0.1 dm cubed, because if it's mostly water, then the density is about the same density as water. Okay, so 1 over 100 grams is 1%. So I converted this to dm cubed because molarity uses dm cubed, and then I converted the grams to moles. So moles over liters gives you the concentration in molarity. Molar mass of iodine, I2, is 254. Okay, so we figured out the concentration of iodine. Now, if we used 5 mils of that, it means we used 0.05 dm cubed, and then we calculate the moles of iodine that were added to our T. So these are the moles of iodine that were added. Remember, we are doing a back titration here, so these moles should be in excess, right? These are the moles of iodine we added, but they are in excess. So our iodine is going to react with caffeine. Some of the iodine is going to react with caffeine, but there'll be extras, and that's what we're gonna figure out using the titration. So the initial amount that we added, here we go. These are the moles. Now we know caffeine reacts with iodine in a 1:2 ratio. Okay, 1:2 mole ratio. If you want to see this equation, you can check the Google Classroom. I have posted a picture under this lab assignment. Okay, so it's 1:2 caffeine to iodine. Okay, and then iodine to sodium thiosulfate is also 1:2. Okay, how are we gonna use this? So let's say the volume of sodium thiosulfate that was used during the titration was 15 milliliters. First thing, we have to convert to moles of sodium thiosulfate, and we take the 15 milliliters here, multiply it or divide it by 1,000 to convert it to dm cubed, and then we multiply that by the concentration of our solution, which is 0.02 moles per liter, and this is the number of moles of sodium thiosulfate that we used in the titration. Okay, now we use the mole ratio that I stated above. We find that the moles of iodine will be 0.0015 moles. These are the moles of iodine that were left over when iodine reacted with caffeine. Okay, so we know how much iodine we started with, and at the end we know how much is left over. So the difference between the two is the amount of iodine that reacted with caffeine. Caffeine and iodine mole ratio is also 1:2. So if we put the moles of iodine left over, we can figure out the amount of not iodine left over, but the amount of iodine that was used by caffeine. We can figure out the amount of caffeine that we have, and that comes up to be 2.2 times 10 to the minus 5 moles of caffeine. The molar mass of caffeine is 194.2 grams per mole. So to figure out the mass, we multiply the moles by the molar mass, and we get this value here, which when we convert it to milligrams is 4.27 milligrams. Okay.